In today's power electronics experiment, we are going to simulate a circuit of AC voltage control using DIAC-TRIAC combination. So let us begin with the schematic creation. So first of all, we have to go to the library and select the components. So first we will select the DIAC. So here is the DIAC, and then we'll rotate this DIAC. Remember, DIAC is a bidirectional device, so you can rotate it in any direction. Then next we go and select TRIAC. So TRIAC is also over here. So we keep it over here. Alright. Then we select the capacitors and the resistors. So here are the two capacitors. And now we require resistors. So one resistor will go over here. Another one will be over here. And one will be acting as a load. So these are all the resistors which we require. Also will require a AC source. So we type voltage and we'll connect it over here. Alright. So now we'll connect them together with a wire. So DIAC will generate the trigger pulses which are required to trigger the TRIAC. Remember, DIAC has no gate control. Okay, whereas TRIAC has got gate control. Both are bidirectional. DIAC and TRIAC both are bidirectional. So we have connected the circuit quickly. All right, and from here to here. Okay, and now we have to connect the ground also. So we'll connect the ground over here, connect it with the wire. Now we'll give the values. So first of all, the source. So we'll right click on the source, go to advance, and then go to sign. Here we can give DC offset as 0, and amplitude will be around 100 volts, and frequency will be around 100 hertz. Rest all the parameters you can keep it blank. Okay, all right. So this is what we have given as a sinusoidal input. Now for the load, this is my load, so I can rename it as RL. Remember, it can be a bulb, which is again a resistive load. So here we are using a simple resistor. So here the value of the resistor is around 100 ohms. This value of resistor is around 10 kilo ohms. The capacitor values are 0.1 microfarad, both the capacitor values. Alright, and this resistor value is again around 240 or 250. Alright, so the circuit parameters are been taken care of, and we can label the input and the output. We want to view the voltage across the TRIAC as well as the triggering pulses at the DIAC, and then also the input and the output. Alright, so for labeling we can right click, go to draft, and then our label net. So here we can connect a label net, we can call it as in, and we can select it as port type as input and connect it over here. Alright, and then connect it with the wire. This is used for for easy plotting. Again go to draft, label net, and now I can name it as out. The port will be output port. Alright, connected with a wire. And also I can create one more label over here. So right click, go to draft, and go to label net, and here I can call it as point A, and this will be bidirectional mode. Okay, I think we have made a mistake over here. The mistake is that over here the DIAC should go to the gate terminal. It's required for generating the trigger pulses, and here we have connected to the anode circuit. So here we can delete it with a wire, and then we have to connect it back to the gate terminal of the TRIAC. So three terminals of TRIAC are MT1, MT2 and the gate terminal. Okay, alright. So now the connections are fine. Now we have to just simulate the circuit. So I'll go to simulate, click on run. Stop time we can give it around 20 milliseconds. That's fine. I click on OK. So it will show some unknown sub-circuit error, that is for the DIAC and the TRIAC. So LTspice is telling us that it doesn't have the model for the spice model for the DIAC and the TRIAC. So we have to download the spice model for the DIAC and the TRIAC. So I'll go to Google. I'll type ST Microelectronics, so st.com. So it will take us to ST Microelectronics website. Click over here. Alright. And here we can go to search bar and search for DIAC-SPICE model. Okay, and I click on enter. So this is the DIAC PSpice model. You can click on the download and save it in the C drive. I've already done that. I'll show it to you. I'll go to PC, local disk, and then program files, then LTC, then LTspice, right? Under LTspice, you go to library, and here is I have saved that file DIAC underscore pspice, right? So I've already done the downloading, so you all can do the downloading. Click on this zip folder, then unzip it and save it in the C drive where your LTspice folder is. Under LTC program files, LTC, LTspice, and then library. So you can save this folder over here. Next, we have to also add the model of the TRIAC. So again, I'll click over here in search, and instead of DIAC, I'll type TRIAC. So yeah, we get around 4 spice models. So out of this, we can select the second one, standard and numberless TRIAC pspice model. So click on the download icon, and it will be creating a file in zip folder. We can unzip it and again save it in the same location. So here is the already saved folder with the spice model, which I've added in the under the library part under under LTspice. So these two files, DIAC underscore pspice and standards numberless TRIAC underscore pspice files have been added in the uh, inside the library folder under LTspice, where the LTspice is stored. And now we have to include these models. So for including the model, let's say we want to include the DIAC model. So I'll go inside the folder. Then I'll right click on the library file. So how do you identify a library file? The type will be lib file. So I'll right click over here. Right click on the S and then click on properties. Oh, sorry for that. I'll right click, then click on properties, and here is the location. So I can copy this location and then again go to LTspice, and now I can add these models. So I'll right click, go to draft, go to spice director, and here I can write a line dot include inc and then paste this line. Okay, now this will not contain the library file, right? So I'll put another slash and then I'll again go back to the folder, and then I'll right click over here, rename. I'll copy this name. Alright, so again I'll go to LTspice and I'll put a slash and then add that dot lib. So in this way the entire part has been added over here. I'll click on OK. So this is how we can add include the spice model of the DIAC. Similarly, we have to do it for the TRIAC. So yeah, so I'll go over here. Again, one more thing is there that we have to decide the component name, all right, for the DIAC. So what we will do, again go to the spice model, right click on the library file and click on the open with. So we will open this with Notepad, and here we have to go down. This is the library file, and here we have to add the name. So as you can see, a lot of parameters have been given over here. A lot of model parameters have been defined. We will go down, and we will select this name as DB3. So the two terminals are DIAC in, DIAC underscore in, and DIAC underscore out. So here are the parameters, as you can see. Okay, so we can add DB3. So I'll copy over here, and I'll go back to the LTspice. I'll right click on the DIAC model, and instead of the name, instead of the value over here DIAC, I'll add over here DB3. All right. Okay. So similarly, we have to do similar things for the TRIAC. So for the TRIAC, I'll go to the folder and right click on the library file, go to properties, and then add, copy the location, then go to LTspice, include this model. So go to draft, spice directive, I'll write dot include, and then copy this part over here. All right. So this is not the complete part, it doesn't include the library file. So I'll go back over here, I'll right click, I'll copy, I'll rename it, pretend to rename, but I want to copy this name, and I'll go back to the library, put a slash, add that name under, dot lib. Okay, so this is the way we can add the library file for the uh, TRIAC. So the first one is dot including the part for the for the DIAC spice model, and the second statement will include the spice model for the TRIAC. All right. So this is the way we can add it, and now I have to name the I include the TRIAC model. Select the TRIAC model which we want. So right click on open with, and I open this library file of spice model of TRIAC over here, and here I will search for one of the modules which I can add, subcircuit. So as you can see, I can scroll down. I want a model starting with BT. So there are a lot of files. Yeah, so I got it over here. BT12. I can select BT12. No specific reason for it. You can select even BTB. That is fine. Yeah, BT12 underscore BT1210. BT12. Okay, BTA12, then hyphen 600B. So this is what I will add, and the sequence of the terminals will be anode, cathode, and gate. So these are the parameters, right? Your VDRM is 600 volt, IGT is around 100 milliampere, holding current is around 50 milliamperes, right? So all these parameters are including in that subcircuit. So I'll right click on this name, I'll copy it, I'll go to LTspice, right click on the TRIAC, and under value I'll paste that number. Alright, so this is the way to add the spice model in LTspice. Alright, now it's the time to simulate the circuitry. So what we can do is, again we'll run on the simulate and click on run. As you can see, this time it's running and it's throwing an error in one line. That is okay, that is, we can ignore this. This is only having an unknown parameter as a star, so we can easily ignore this part. All right, so now we will plot input. So I'll click on the input part. This is my input. As you can see, sinusoidal waveform with a frequency of around 100 hertz and amplitude of around a peak value of around 100 volts. Now I'll click over here, click on add plane plot. I'll add, in fact, two more plane plots, and I'll click keep this over here. Next, I have to plot voltage across the TRIAC. So voltage across the TRIAC, I can name it as instead of calling it output, I can name it as TRI. All right. Okay. So voltage across the triac. Before that, I want to plot the gate pulses. So let me see. Yeah, this is U1 and X. Okay. So I right click over here, click on add trace, U1 and X. So here the gate pulses I will want to plot. I wish to plot the gate pulses. So these are the gate pulses, gate current pulses for the DIAC. And now I want to plot the voltage across the triac. So I right click over here, click on add trace and click on voltage across the triac. As you can see, since it is a triac is a bidirectional device, semiconductor power device. So as soon as the gate trigger is applied via the DIAC, it it follows the input and then it triggers on the DIAC is on until it receives the trigger pulses, right? So the voltage across the track will be very small, and then again it will follow the input in the negative half cycle because it's bidirectional, and again at the encounter of another trigger pulse in the negative half, it will again start conducting. Okay, then the same cycle will keep on repeating, right? So the other half of the voltage will appear across the output. So I will be plotting the voltage across RL. Yeah. So this is my voltage across RL. I'll push it down and I'll give some a little bit of dark color over here. Okay, so this is my voltage across the load. As you can see, the voltage across the triac plus the voltage across the load will be equal to V in according to the KVL. All right. So V in is equal to voltage across the load plus voltage across the triac. All right. And that is what is exactly happening over here. Whenever the triac is off, the output voltage is 0, and whenever the triac is on, it will follow the input, as you can see clearly. So this is how we can control the AC voltage at the input side, and at the output side it will be controlled with the DIAC-TRIAC combination. All right. So for your lab experiment, what you can do is you all can experiment with the values of RL, and also you all can change the frequency and check it out how is the behavior of the DIAC-TRIAC combination using AC control. All right. So this is the way you can have this circuit schematic. Also, if you want to plot the gate voltage, so it's VA. So I can have another plane plot and plot the value of VA. So this, as you can see, this is again the trigger pulses which are behaving in a similar manner as the gate pulses, as the gate current pulses, as you can see. All right. So this is your VA, which is being given to the triac to trigger it on upon the arrival of the gate pulse. Okay. So both the gate voltage as well as the gate pulses have been applied over here. All right. So in this way, you can control the AC voltage at the output using a DIAC-TRIAC combination. All right. So you have to take the print screen of the schematic, and also you need to take the print screen of the output, as you can see. All right. So that's it for this experiment. Complete your work on time and also submit on time. So thank you.